Hey guys, welcome to this Easy Maths video. Today we are looking at the Junior Maths Challenge from 2019. Question 1 says, how many minutes is it from 23:35 today to 1:15 tomorrow? Okay, so to work this out, we know that to get from 23:35 to midnight, that takes 25 minutes. And then to get from midnight to 1:15, that will take an hour and 15 minutes. Now 1 hour is 60 minutes, so we're going to have 25 minutes plus 60 minutes plus 15 minutes. 25 plus 60 is 85, 85 plus 15 is 100. So therefore our final answer is A, 100 minutes. Question 2 says, which of these is equal to 0.1 plus 0.2 plus 0.3 minus 0.4, all divided by 0.5? Okay, so if we write this out again, then using BODMAS, so we're going to start with B first, which is the brackets. So we can simplify what's in the bracket first, which is all of this here. So we're going to have 0.1 plus 0.2 plus 0.3. That gives us 0.6. And 0.6 minus 0.4 gives us 0.2. And then we just need to do 0.2 divided by 0.5. So that's 0.2 divided by 0.5. So what we can do is we can multiply both the numerator and the denominator of this fraction by 10. 10 over 10, so that's going to give us 2 over 5. And 2/5, if we multiply both the denominator and the numerator by 2, well, that just gives us 4/10. And 4/10 is the same as 0.4. So therefore our final answer is E. Question 3 says, Sam has eaten 3/4 of the grapes. What is the ratio of the number of grapes that remain to the number Sam has eaten? Okay, so if we represent the number of grapes with the letter G, so number of grapes is represented by G. So now we can write out the ratio in terms of G. So it's the ratio of the number of grapes that remain. So the number of grapes that remain is going to be 1/4, because it says that Sam has eaten 3/4 of the grapes. So there's 1/4 of the grapes left over. So we say that's 1/4 of G. And then this is to the ratio of the number that Sam has eaten. Well, the question says that Sam has eaten 3/4 of the grapes. So that will be 3/4 of G. So it's 1/4 of G to 3/4 of G. So now we can divide this ratio through by G. So the G's end up cancelling each other out. So we get 1/4 to 3/4. And now we can multiply this ratio through by 4. And we get the ratio 1 to 3. And that is answer A. Question 4 says, which of the following 5 shapes can be cut into 4 pieces by a single straight cut? So if we look at these shapes individually, we can draw a single straight line going through the center of each of these shapes, and then we can see how many shapes they can be cut into. So if we look at the first one, A, if we draw a straight line going straight down the center, we can see that this will be split into 2 different shapes. So it can't be A. If we do the same for B, that will also be split into 2 separate shapes. So it can't be B. Now C is slightly different. If we draw a straight line for C, you should be able to see that it will split into 3 shapes. We've got one here, the second one here, and the third one here. So it can't be C. If we do the same for D, then this will just be split into 2 shapes, this shape here and this shape here. And lastly, if we do the same for E, so how many shapes do we get here? Well, we get 1 here, 2 here, 3 here, 4 here, and we're looking for a shape that can be cut into 4 pieces. We can obviously see here that shape E can be cut into 4 pieces, so the final answer must be E. Question 5 says, on Aoife's 16th birthday, Buster was 3 times her age. On Aoife's 21st birthday, how old was Buster? Okay, so if Buster is 3 times Aoife's age, then we just need to do 16 times 3. So 16 times 3. So we can do 3 times 6, which is 18. 3 times 10, which is 30. And if we add those two results together, we're going to get 8 plus 0 is 8. 1 plus 3 is 4. So we get 48. So that means Buster is 48. And now we need to work out how old Buster is going to be when Aoife is 21. So we can work out the difference between 21 and 16. So 21 minus 16, that gives us 5. And now all we need to do is add that age onto Buster's age. So we're going to get 48 plus 5, which is 53. So Buster must now be 53. So our final answer is C. Question 6 says, which of these is closest to 7? So we can compare each of these answers and work out their difference between 7, and then whichever answer has the smallest difference must be the answer which is closest to 7. So if we look at the first one, which is 7.09, so we're doing 7.09 minus 7, so we can write that as 7.00. Then 9 minus 0 is 9. 0 minus 0 is 0, 7 minus 7, which is also 0. So that gives us an answer of 0.09. We can then do the same for B, which is 6.918. So we can write that as 7.000. So we're going to have 3 decimal places here. Subtract 6.918. So the way we deal with column subtraction is we can't do 0 minus 8. So what we have to do is we have to borrow 1 from the 7, okay? So by borrowing 1 from the 7, that reduces 7 to 6. Okay, and we can place a 1 in front of the number after it. So that's 0 in this case, so we're going to have 10. But then we're going to need to borrow 1 from 10. So that brings 10 down to 9. And we can place a 1 in front of the next 0. And then again, we need to borrow 1 from this 10, so that brings this 10 down to 9. We can place a 1 in front of this 0. So now we've got 10 minus 8, which is 2. And then if we just go along, we're then going to have 9 minus 1, which is 8. Then 9 minus 9 is 0. And 6 minus 6 is also 0. So this answer gives us 0.082. If we look at C, we're going to have 7.17 minus 7. So we can write that as 7.00. So 7 minus 0 is 7. 1 minus 0 is 1. And 7 minus 7 is 0. So we're going to get 0.17 for that answer. Okay, and D is 6.7. So we can do 7.0 minus 6.7. So if we borrow 1 from the 7, that's going to reduce 7 to 6, and then we can write this as 10. 10 minus 7 is 3. 6 minus 6 is 0, so this is just 0.3. And E is 7.05. So it's 7.05 minus 7.000. 5 minus 0 is 5. 8 minus 0 is 8. 0 minus 0 is 0, 7 minus 7 is also 0, so that gives us 0.085. Now, if we write each of these differences so that they've got the same number of decimal places, we can then compare each of the answers to see which is the smallest. If we write them to 3 decimal places, then that will make it easy for us to compare. So this first one we can write as 0.090. This one is already at 3 decimal places, so that's 0.082. This one will be 0.170. This one will be 0.300. And this one is also written to 3 decimal places, so that's 0.085. Okay, so we should be able to see that the smallest difference is this one here, 0.082. And that was answer B. So our final answer is answer B. Question 7 says the shortest street in the UK, Ebenezer Place in Wick, is 2.06 metres long. The Trans-Canada Highway, one of the world's longest roads, is approximately 7,821 kilometres in length. Approximately how many times longer than the street is the highway? Okay, so the key word to this question is approximately. So we need to take each of these figures and approximate them by either rounding them up or down. So 2.06 metres, we can approximate this to 2 metres. So we're rounding down to the nearest whole number. And 7,821 kilometres, we could approximate to 8,000 kilometres by rounding up to the nearest 1,000. So now we need to calculate how many times longer than the street is the highway. So the highway is 8,000 kilometres. So there's a slight difference here with units. We've got metres here and kilometres here. So we can easily convert between kilometres and metres because we know that a kilo is equal to 1,000 or 10 to the power of 3. So 8,000 kilometres will be equal to 8,000 times 1,000, which is 8 million metres. And now we just need to take 8 million metres and divide it by 2 metres. So we get 8 million divided by 2, and that is 4 million. So the highway is 4 million times longer than the street. And we've got an answer there, which is A. So our final answer is A, 4 million. Question 8, the diagram shows a kite PGRF inside a rhombus PQRS. Angle PGQ is equal to 35 degrees. Angle PFS is equal to 35 degrees. Angle PQG equals 120 degrees. And angle PSF is also 120 degrees. What is the size of angle FPG? Okay, so I've enlarged the diagram, and angle FPG is going to be this angle here, so I'll label that as X. Okay, so the first thing I'll notice here is that this rhombus PQRS contains 2 smaller triangles, which are here and here. So that's PSF and PGQ. And both of those triangles have the same angles. They've got 2 angles and they've got the exact same lengths. We can see that one is just a reflection of the other. So that means that we can work out what these missing angles are going to be just by taking the sum of 120 and 35 and taking it away from 180 degrees, since the angles in a triangle add up to 180 degrees. So that is 120 plus 35, which is 155 degrees, and that is 180 degrees minus 155 degrees, which is 25 degrees. So both of these angles are 25 degrees. Now we can see here that the angle PSR, which is this angle here of 120 degrees, and then the angle PQR are the same. So what that means is angle SPQ will be equal to angle SRQ. So angle SPQ equals 25 degrees plus x plus 25 degrees. So that is just x plus 50 degrees. So that means angle SRQ will also be equal to x plus 50 degrees, since they are the same. And now what's the last thing we know? Well, the angles in a quadrilateral add up to 360 degrees, since they can be split up into two triangles. So then that means, since I've now got values for each of my angles, I can add them all up and set them equal to 360 degrees. So that means I'm going to have 120 degrees plus 120 degrees plus x plus 50 plus x plus 50 equals 360 degrees. And now, since x is angle FPG, we just have an equation where we're solving for x. So if we simplify the left-hand side of this equation, we're going to have 120 plus 120, which is 240. Then 50 plus 50 is 100. And 100 plus 240 is 340. And then we've got the x plus the x, which is 2x. So we're going to have 2x plus 340 degrees equals 360 degrees. Now we can subtract 340 degrees from both sides, so we get 2x equals 360 minus 340 degrees. That's 20 degrees. And now we can just divide both sides by 2, so we get x equals 10 degrees. So angle FPG is also equal to 10 degrees. And that is answer A. Question 9. What is 50% of 18.3 plus 18.3% of 50? So remember, of just means times, and obviously plus is addition. So we can write this as 50% times 18.3 plus 18.3% times 50. Now we can convert these percentages into fractions. So 50% is the same as 50 over 100, and this is times 18.3, plus 18.3% is the same as 18.3 over 100 as a fraction, and then we're multiplying this by 50. Okay, so 50 over 100 simplifies to 1/2. So I can write this as 1/2 times 18.3. Now in here we're going to do something quite clever. What we can do is we can combine the numerators. So we can multiply 18.3 by 50. Okay, so this is just the same as saying 18.3 times 50 over 100. Now what I can do is I can rewrite this again, but I can pull out the 18.3 and just leave this as multiplying 18.3 by 50 over 100. And now I'm just going to have 1/2 times 18.3 plus 18.3, and 50 over 100 is the same as 1/2, so I'm multiplying this by 1/2. So 1/2 of 18.3 plus 1/2 of 18.3 is just going to give me 18.3. And I've got an answer of 18.3, which is answer B, so therefore my final answer is B. Question 10 says, what is the last digit of the smallest positive integer whose digits add up to 2019? Okay, so if we look at A first, so A is saying that what would happen if the last digit was 1. If I do 2019 divided by 1, I'm obviously going to get 2019. So what I could say here is I could have a number which is just made up of digits of 1s, and there could be 2019 digits here. Okay, so this number has 2019 digits, so that's quite large. So if we look at the next one, so B is 4, so here we could do 2019 divided by 4. So here we could use short division. So we say how many times does 4 go into 2? Well, that's 0. Then how many times does 4 go into 20? That's 5. Then how many times does 4 go into 1? That's 0. And how many times does 4 go into 19? That's 4, with a remainder of 3. Okay, so we can write that as 504 remainder 3. So here we're going to have a number which is going to include 504 fours, but it's also got to include a 3 because we have a remainder of 3. Now we want the smallest possible positive integer. So to make this number as small as possible, we're going to replace this 3 at the front. So it will be 3 followed by a load of 4s, and there happens to be 504 fours in this case. Now, and as you can see, when I did 2019 divided by 4, that gave me a much smaller number than when I did 2019 divided by 1. So what's going to happen is when I go through each of these last digits, my number is going to get smaller and smaller and smaller. So instead of checking C and D, if we just go straight to E, which is the largest possible answer we've been given, then we could just do 2019 divided by 9. So again, if we use short division, so we say how many times does 9 go into 2? That's 0. How many times does 9 go into 20? That's 2 with a remainder of 2. Then how many times does 9 go into 21? That is 2 with a remainder of 3. And how many times does 9 go into 39? That's 4 with a remainder of 3. So our answer here is going to be 224 remainder 3. So here we're going to have 224 9s and 1 3. So again, we want to make this number as small as possible, so we're going to place a 3 at the front. So it's a 3 followed by 224 9s. Okay, and as we can see, this is a 225 digit number, and that is smaller than any of the other answers we have checked. So therefore, our answer must be E, which is 9.